Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem belongs to the playlist Momentum. Please read description because it shows you all prerequisites to better understand this problem. And the problem talks about the boat. So this is a boat and the man who stands here on the tail of the boat, and then he moves to the nose of the boat. And we all know that as he moves in front, the board will start move back. And so the board will be in this position after he moves. And so he will be standing here now, in front. And we know the mass of the boat, and we know the mass of the human. The mass of the boat is 320 kilogram, and the mass of the human is 80 kilogram. And they give us the length of the board. The length of the board, let's say 6 meters. Pretty small board. Maybe it's a big board, I don't know how you judge. But anyway, they want to ask us what happens when you go to the nose, how much the boat will move with relation to the bottom, with relation to the banks, and what would be the real distance with relation to the bottom and the relation to the banks that this person will cover. And the easiest way to solve this problem, of course, is with the center of mass. So, center of mass, and all is happening in one direction, x. So let's put x here, and of course when we're putting x, so far it's just an arrow. Just an arrow like bow and arrow, it's not an x, not an axis. We have to put 0. Where is 0 on this x? And I suggest we put it the initial position of the tail. We can put anywhere, but let's put 0 here. And let's use the formula for center of mass, and it would be mass of the boat, center mass of the boat. We can say that the boat it has its own center mass. We presume that it is a mass point, or point mass rather, point mass, and this position, let's say, is D. Original position is D. And so it would be m multiplied by d plus mass of the person. And in the beginning, it is 0. Because we choose in the coordinate system like that. We can choose anyway, but then it will be not 0, but it will be adjusted in the next step. And here would be m plus m. And then x center mass, and center mass will not move because it's a closed system. And in the closed system, they can walk as much as you want, but center mass will not move. It's like you cannot pull you out of the swamp, pulling yourself up, like some personage of the tale suggested he did it to him. No, you cannot, because it's an enclosed system, and center mass of the system stays in the same spot. So, I say center mass of the system, but system of this and this. So this center mass is somewhere here. This is the position of the center of mass, because this is center mass of the boat, and this is center mass of the human. The boat is heavier, the human is lighter. So it's somewhere here closer to the center mass of the boat. And now once everything moved, and let's say it moved and we don't know how much x. And we all know that if the man goes this way, that it moves this way. So let's say that this distance would be L. This distance is L. And L would be negative. But the distance will be L, because the tail of the boat and the whole boat will move this way. So center mass after everything moves to the L back would be D minus L, because the boat, this would be here, it moved, and it would be D minus L, this would be L, this distance would be L, and so this distance would be D minus L. So D plus, with human it would be different. Human will move all the distance L to the nose, but also the boat will move L lowercase to the left. So position here would be again total length L minus L, how much the boat will move back. And then this would be M plus M again. And this thing equals this thing, because center mass doesn't move. So I can write that this thing is md, and m0 is 0, and I put m plus m, which will cancel it out, but I will put it to be precise. md minus l, I started to write this thing, plus m lowercase l minus l, m plus m. I multiply everything by m plus m, by this bracket, so it will cancel out, and I will have md equal m, and I will open brackets, md minus ml plus ml minus m lowercase. And what I immediately can say is that those two are the same, so this d is cancelled out. Originally maybe we all wanted to say that d is in the middle of this distance L half. We wanted, I had a temptation to write this, but I didn't, because we don't know, maybe there is an engine somewhere in the boat, maybe the boat is heavier on the tail, so we don't know where center mass of the boat is located, and it doesn't matter, because this cancels out. And so what is not known in this equation? Mass is known, L. L is what we need to find out. So we're finding it out, we're moving it all together and factoring it out. Equal m lowercase l, and we immediately receive that L equals ml divided m plus m. And this is how much the boat moved. The boat moved like this. And they ask us how much the human, and we can put the numbers, or we can put the numbers later. And then they wanted to know how much the human moved. And I can tell right away from the principle of symmetry. I can say that L human, the distance human moved against the bottom, should be m, L, m plus m. Because boat and human are kind of the same, and its result should be symmetrical. I can just say that if the boat moves by this distance, that where m is the mass of the human, and this would be the same, L would be the same, sorry, this is L capital, m would be the same, L would be the same, and the bottom would be the same, but let's change, this is I know, but let's check how it is in real world. So the man moved distance L minus this ml divided m plus m. So realize what I am doing here. I know that the result would be like this. Now I am proving that the result should be like this just from the simple geometry. So the man works L minus L. The man works the fall distance, which is L. He works this distance of the from the tail to the nose, it's L capital, minus whatever boat moved back. And so I, of course, bring it to the common denominator, and I have L capital M plus L capital L capital M capital, and minus this ML. And those two go away, and I receive this result Ln over this M plus M. And this is exactly the same result that I received from the principle of symmetry, that human and person are symmetrical. So I will find L here, for example. I have mass is 80, so it would be 80, and this 2 would be 400, and distance is 6, so it would be 6/5 of the meter, 6/5 meters, or 125 meters. This is how the boat will move. And the man will work 6 meters minus 125, and it would be 475 meters. So the man walks 6 meters, but the boat moves back 125, so the real displacement of the man against the bottom and against the earth and against the banks is only 475. So he walks a lot of distance, but he pushes boat back, and that's why it's all happening. And I hope you liked it. You can subscribe and push bell, and I see you next time. Thank you.